Marcel Schmidt, EnzyPep, CEPS Technology, a more efficient and greener route to future peptide drugs.
Okay, the story begins with Emil Fischer at the turn of the 20th century when he coined the name peptides. They have been owned by evolution for millions of years and represent nature's chemically most diverse toolkit. Their outstanding selectivity and efficacy still leads to a fast-growing interest of the use of peptides in medicine. The therapeutic potential addresses the full scope of medical disorders, ranging from cancer treatments to diabetes. So, most of you will probably take a peptide-based drug once in your lifetime. To manufacture these uniquely designed peptide drugs, of course, efficient processes for their production on an industrial scale are required. However, conventionally used solid-phase peptide synthesis has remained almost unchanged since its invention in the 1960s. Peptide yield and purity usually decrease with peptide length and often result in cumbersome purification procedure, therefore also accounting for the generation of large amounts of waste. So, as you can see, this set of techniques is still far from perfect. To overcome some of these difficulties, chemoenzymatic peptide synthesis represents a greener and more sustainable way towards the production of future peptide drugs. Chemoenzymatic peptide synthesis is a combination of, on the one hand, conventionally used solid-phase peptide synthesis of smaller segments, on the other hand, an enzymatic condensation or ligation of these smaller peptide segments in water. And these smaller peptide segments can be produced in much higher yield and purity compared to the longer counterparts. And these smaller segments can then be coupled together in a racemization-free manner using an enzyme. For example, using peptiligase, which is a highly efficient and selective peptide ligase we recently discovered at EnzyPep. So, as a result, the overall yield and purity of a process can be significantly increased. So, just to give you an example, for instance, we recently developed a process for the highly potent immunomodulating and particularly difficult to synthesize drug tyrosine alpha-1. And this process is characterized by a more than twofold higher overall yield, and we reached a cost price reduction of over 50%. So consequently, the chemical footprint of the process and, more important, also the cost could be significantly reduced. And just to come to an end, and to conclude, we at EnzyPep, we focus on new innovative processes for peptide drugs and help to pave the way towards a cost-efficient, more sustainable production of future peptide drugs, and therefore also making peptide drugs available to everybody. Thank you.